This is part 3 of the video introduction to activity 3.4, turning point form. We have seen that the h in the quadratic function y equals a times quantity x minus h squared plus k will shift the graph of y equals x squared either right or left. Similarly, the k will shift the graph up or down. For example, if y equals a times quantity x minus 3 squared plus 4, then the graph of this function is the graph of y equals x squared shifted 3 to the right and up 4. This helps us see that the turning point for this particular function is 3, 4. We can now use our completing the square technique to convert any quadratic function into a turning point form. Let's look at two numerical examples to see this in action. We'll start with the case where our leading coefficient a is 1. Our function is y equals x squared plus 4x minus 6. We start with our function and then we isolate the ax squared plus bx terms. We just simply put brackets around them. The square brackets are just isolating them. It's not changing any values. Now we'll compute b over 2a and b over 2a squared. Here b is 4, so b over 2a, because a is 1, is 2, and 2 squared is 4. Now we'll add and subtract b over 2a, quantity squared, to complete the square. Graphically, we have our factor rectangle with region 4 missing set equal to 0, and we have our c just separated here, not on the right side. And then we add b over 2a quantity square to our factor rectangle and subtract it so as to not change the value. Now we can factor x squared plus bx plus quantity b over 2a squared into x plus b over 2a quantity squared. And we can add our numbers out here. So we simplify and we can see that our turning point here is -2, -10, and we have our turning point formed. We can check by multiplying out our turning point form and making sure that we have our original function. In the next example, our leading coefficient is not 1. We can still use the completing the square technique, but we just have to be careful about managing our leading coefficient and the terms we add in. Now we have 2x squared plus 3x minus 6. We start with our function and we isolate our ax squared plus bx term. Now we'll factor a out. So 2 we factor out from x squared. When we factor 2 out from 3x, we simply divide by the 2. 2 times 3 over 2 is 3. So we factored out our a term. It's just hanging out there. Now, inside, remember inside here, we have x squared plus 3 over 2x. Inside, a is 1 and b is 3 over 2. So b over 2a is 3 over 2 times 1/2, so 3 over 4. When we square that, we get 9/16. So now we'll add 3 over 4 squared on the inside, and we need to also subtract it. But remember, we're really adding in 2 times 3 over 4 quantity squared. So we need to subtract 2 times 3 over 4 quantity squared on the outside of our brackets. Now we can factor, so on the inside we have x plus 3 over 4 quantity squared, our 2's still out there, and then we can combine all our numbers on the outside by adding fractions, and we end up with y equals 2 times quantity x plus 3 over 4 quantity squared minus 57 over 8. And this allows us to have our turning point as well. Again, we can check by simply multiplying everything out and checking that we get our original function. You might find checking graphically by graphing both functions is also helpful.